Hello friends, today I will discuss about difference between low impedance and high impedance restricted earth fault relay. So connection diagram for restricted earth fault relay, that is, one is high impedance type and another is low impedance type has been shown in this diagram. The left hand picture is shown for the high impedance restricted earth fault relay connection diagram, and in the right hand side of the picture you can see the low impedance restricted earth fault relay connection diagram. So in case of high impedance RF protection relay, the CT polarity should be proper, that is for phase CT or bushing CT. That is, the P1 shall be connected towards the bus side and P2 shall be connected towards the transformer side. And for NCT the P1 shall be connected towards the uh, earth side and P2 shall be connected towards the neutral of the star winding transformer. So in the secondary side, all the S1 terminal are connected together, and similarly all the S2 terminal of the bushing CT or phase CT and neutral CT are connected together, and these two terminal are connected or taken via cable and connected to the two terminal of the restricted earth fault relay, and this relay is connected via a high impedance in series with the relay. But in case of low impedance relay, there is no requirement of resistance of high impedance. Here only the CT secondary is connected to the red, yellow and blue phase coil of the numerical relay, and again another terminal is sorted together to form the neutral of the CT and taken back to the CTJB. Again for the polarity shall be proper, that is P1 for all the phase CTs shall be connected towards the bus side and P2 shall be connected towards the transformer side, and for NCT it is similar to that of the high impedance RF protection connection. But in case of secondary connection of the NCT, the two terminal taken to the neutral another coil which is called the sensitive coil or ion coil of the RF relay, that is the numerical type. Again the CT polarity connection in the relay should be proper. So what are the key difference between high impedance RF protection and low impedance RF protection? So from the above figure we can see that the CT wiring is very simple for low impedance RF protection relay, but in case of high impedance RF protection relay, CT wiring is somewhat complicated. So another the key difference is the CT ratio. In case of high impedance RF protection relay, all the CT ratios should be same. That is, bushing CT ratio of all the phase and with that of the NCT ratio must be same. If the phase CT ratio is 1000 by 1, then NCT ratio must be 1000 by 1. But in case of low impedance RF protection relay, the phase CT ratio with that of NCT ratio can be different. So under through fault condition, the stability is maintained by a stabilizing voltage that is calculated by a maximum through fault current, and this maximum through fault current is divided by the CT ratio, and this fault current is multiplied by the secondary CT resistance plus the cable resistance plus relay burden. So by multiplying this we can get the stabilizing voltage, and the value of the resistor we have to calculate it divided by the stabilizing voltage divided by the relay setting minus relay burden. So this is the calculation for the resistance which is connected in series with the relay. So purpose of the high impedance in series with the restricted earth fault relay in order to provide the stable condition under through fault condition if either of the phase CT or in CT saturate. So here VK should be all VK for all the phase CT and neutral CT should be same. Again the knee point voltage should be greater than equal to 2 times of the stabilizing voltage. But in case of low impedance RF protection, stability under through fault condition is maintained by bias characteristics of the relay. The characteristics for low impedance RF protection relay has been shown in this diagram. Here ID is the differential current. Differential current is given by sum of the vector sum of the three phase current, that is IA plus IB plus IC plus K into IN. IN is the neutral current and K is the factor which is given by NCT ratio divided by phase CT ratio. And bias current is the average of the maximum of three phase current plus K into IN. So if IA is the maximum current, then IA is taken and plus K into IN factor, it is multiplied and it is divided by a factor 2, then we get the bias current. It is more or less similar to the differential protection relay. In differential protection relay, the bias current is I1 plus I2 by 2. Here I2 is given as the K into IN and I1 is the maximum of the three phase current. So under through fault conditions, the bias current will be more, but ID will be 0. But under fault inside the RF protection relay, there will be a differential current. If differential current is more than 10% of the rated current, that is the initial setting of the differential current, then relay will send a trip signal. And here two slope is given. The initial slope, which is K1, normally K1 is set as 0 to 20%, and the higher slope is given above the rated current. Normally IS2 is set as uh, rated current, and K2 is the higher slope, which is given as 50 to 80% in order to provide through fault stability if any of the CT saturate. So in case of high impedance RF protection relay, since a resistance is used in series with the RF protection relay, so under internal fault condition, there is a possibility of the peak voltage developed maybe greater than 3 kV. If this peak voltage is developed under internal fault condition is greater than 3 kV, then a metro cell is required in order to safeguard the relay. So VP is the peak voltage developed under internal fault condition, which is given by equation VP is equal to 2 into root over of 2 Vk into Vf minus Vk. Vf is the voltage developed under internal fault condition. But in case of low impedance RF protection, no such metro cell is required. So in case of high impedance RF protection relay, there is a calculation required. One is stabilizing voltage, another is RS, that is the high impedance which is connected with series with the RF protection relay. Again calculation for VP. Again we have to match the VK with the stabilizing voltage, which is in pair with the stabilizing voltage, that is VK must be greater than equal to 2 times of the VS. But in case of low impedance RF protection relay, no such complex calculation is required. Only setting is sufficient to provide the protection. So the in terms of cost, high impedance RF protection relay is economic, but in case of low impedance RF protection, since it is numerical relay, it is more expensive compared to the high impedance RF protection relay. So these are the key difference between high impedance RF protection and low impedance RF protection relay. So friends, if you like my video, then do subscribe my channel and also press bell button for notification of videos to be uploaded in future. Thank you for watching this video.